Before we move on to the next section, I want to just quickly run through what we have covered in this section. Let's do a little recap. No coding. Let's take a break, take a step back, and look at our code base. So firstly, I'm going to pull up our architecture again. So this is more or less what our architecture looks like. The number of managers that I have here doesn't really matter. What matters is that we have our SwiftUI views, which are in this tree hierarchical structure. They have an environment, and then in the environment, we are injecting a bunch of observable objects, which we have called managers. There are other code bases that might have called these stores, or it might have called these repositories. I just call them managers because that's how I learned to code. When we created our services, we started with structs, and we put the structs directly into the environment. We did that using the environment values macro, the @entry macro. But then we came to a situation where we preferred to have a class in the environment so that the class could hold some data in memory. For example, when we added the auth manager, we wanted to keep the user's auth in memory at all times. We also did that for the user manager. So we came to this structure where we inject the service, something that is sendable, into the manager, which is an observable object, and then we put the object into the environment. Now, we should note that we don't have to do this structure all the time. We could still put the services into the environment. We also could just use singletons or not use any sort of injection mechanism. We can also just write all of this code in our views. But the reason I've gone with this structure is because I think it is pretty universal that almost any app in almost any situation can fall into this structure. So I use this almost all the time when I'm building apps. Now, it's important to know how to do this, but let's also remember that this takes time to set up. It takes time to maintain the mocks. It takes time to maintain the dependencies and to add the classes. And so there are definitely cases in your app where maybe we just hack something together. And then if we later want to improve the code base, we move to something closer to this. For me, I'm pretty comfortable with this, so I'll often do this as soon as I start building apps. But the big benefit here is that we can now basically mock out any of our views and any of our data. So if we come back into our actual code base, we are initializing our dependencies at the root of our app. And only when we are running the actual app are we using Firebase. And all of our previews are actually using all of our mock data. This allows us to run any SwiftUI preview with completely mock data. We can mock the user signing in or the user signed out. We can mock data flowing in or no data or errors. We can mock slow loading. And it really just opens us up to how we can maintain the code base. So for example, in our Explore view, we added a whole bunch. We added 3 different previews. So we have a preview that does load, one that loads 0 data, and then one that has really slow loading. So although this took us a little extra time to set up, this setup is really going to help the business in the long run because now all of our engineers can see all of these edge cases in the preview at all times. So if I need to come back in here in 6 months, I know exactly all the cases of how this screen looks. And I also know all of the edge cases that the QA is going to find anyway. So I can test out slow loading automatically in the environment. Another thing to point out that we worked on, so in our services folder, we kept ourselves nice and organized here. When we were dealing with these dependencies, such as the auth data or the OpenAI data, let's go to our AI service. So we had our OpenAI service. We put in some extra code in most of our services to convert the external data models into local data models. So for example, in the OpenAI service, we had to convert the OpenAI chat into our AI chat model. And we also did the reverse where we converted our AI model back to the OpenAI data model. And we did that same structure for the Firebase auth service, as well as some other services as well. So in the auth service, we took the authentication user and converted it to a user auth info. This is another layer where we did not have to do this in our code, but it's really going to help us, especially with Swift concurrency, because we're taking any sort of data model that we don't have control over, just creating a replica version in our code base, and we're making sure that our replica version is sendable. So then we can send our version all around our code base. We know exactly how it's going to work. And most of our data models, if not all of them, are immutable structs. So we made these constants in here And we are being really conscious of how we edit the data and mutate the data inside these structs. One more example of this is when we did our Swift data, the avatar entity, which is our Swift data entity, this is something that we did create in our code, but we kept it localized to the Swift data code. So the entity here is not sendable. And so therefore we created a one-to-one mapping between the entity and our avatar model so that we could use our avatar model across our whole app, but only use the entity when we are saving to Swift data. I'll say it again, this is not something that we needed to do, but it's something that's really going to save us with lots of Swift concurrency warnings and errors if we did not do it. It also just gives us full control of how our data models work in all of our views. Because when we start thinking about the architecture, which we're going to do in a future section, there is essentially going to be a separation between the views and the data layers. Right now, it's all pretty coupled, still all together, even though we have broken it out into different functions, it's still all in the view. But when we go and we break these out to more distinct sections in our code base, we'll see that these backend services are quite far removed from the views. So the views are going to love our data models, and then the backend services are going to love these entities. I'll also point out when we created all of our data models, we added in mocks. So we mocked not only the data services, but also all of the data models. And then we very easily could inject these into all of our previews. For example, the mock avatar service. We added code so that we can inject an empty array, a full array, we can add delay or show error into our mock avatar service. We could even go further, for example, when we get into testing, where we create multiple instances of mock avatar service. I could create another struct called mock avatar service 2 that conforms to the same thing. And now I can have another custom implementation of how the mock's going to work. We made these basically just generic mocks because that suits our use case right now. But this opens us up to completely manipulate the data however we want. So that's basically what we did in the last section. The overarching thing that I have not talked about is that we built a really cool app here. So our app is actually pinging the AI, creating avatars. So we can come into our profile screen. I can create an avatar. Let's create one called Chris. Chris will be an alien that is walking in the city. We can actually generate AI images here. Hopefully it gives us a good image. Again, this is not the best AI image generator. That's pretty cool. Chris is walking in the city. We can save it. We actually are writing that to our backend. We have our screens automatically updating. We can go in and we can talk to Chris. We can say, hey there. And now we get actual AI responses from Chris, who's actually acting like an alien. Where are you from? Let's see what he says. From a distant planet in a far-off galaxy. We got our modals working here. We can see Chris is an alien that is walking in the city. And we can talk to him, and he's got an actual personality, which is pretty cool. We learned how to do that with the AI. And now that we actually have a chat, when we go to our chat screen, we should be able to see updates in real time that Chris is our most recent chat, and he's in our recent chat history. And I can even jump in here and I can see our chat syncing to and from Firebase. We put in some work with reporting users and actually setting that up in a backend. We put in some custom error messages and alerts like this one. And honestly, after everything we've done, all of our mocking, all of our data services, I think it is actually a pretty smooth user experience at this point. This is looking great, and I hope you guys are enjoying this course. We are about 1/3 of the way through the course, which is kind of crazy, but the core of the app is now set up. The next section of the course is going to be basically improving this, getting us ready to actually launch it into the App Store. And then the last section is going to be just taking our current code base and adding more architecture. So this is our core app. I hope you guys like it. It does seem pretty cool to me. It is actually fully functional. And I hope you guys are still excited to get into some of the stuff in the next section. And before I wrap up this video, I will note that the next lesson is a quiz. It is a quick 10-question quiz to quiz you guys at a high level on if you've been actually comprehending some of the stuff that we learned in this section. It's going to talk a little bit about what sendable means, what actors versus classes are, and how they work. It's just a quick 10-question quiz, but I'm excited to see how you guys do. So good luck on that. And again, my name is Nick. This is Swiftful Thinking, and I'll see you in the next section.